Okay, hey, great. So hey, it's about 4 after. Let's get rolling. It's Monday, July 12th, which reminds me, SolarWinds is going to announce a stock split today. I should probably go look at the stock market. Random side note. So today is the 12th. It's the WebAssembly filters meeting, one of many different meetings that we have in Layer 5 community focused on service meshes and related tech. It won't be too long before there will be other people who are hosting this call. And that might have started today. Pranav is working to backfill a missing speaker, a missing presenter. And so today, as a reminder, since last time we met, is that last time we met, we said that there are any number of us here who are still learning in this area, which makes a lot of sense to me because the vast majority of the world is still learning these newer technologies. And so WebAssembly as part of that core focus is certainly an emerging technology. WebAssembly as a concept and as a, wow, gosh, what would you, as a write once, run anywhere framework technology is relatively new unto itself, but even newer with respect to service meshes. This last KubeCon, which was, I don't know, a couple of months ago or so, had its first WebAssembly day, just like a single track conference that was associated to KubeCon, in which people presented. That same thing will be happening at the upcoming KubeCon. So actually opportunities for your presentations here to potentially be submitted there. I would suggest that they'll need to be even more advanced than they are today, but we're on the right path. Good. Well, on that, so we had a number of topics lined up with respect to knowledge sharing, mostly. People were going to go off and try to digest a few pieces of technology and share what they could over the last week. So leading us off, I think, is Samir. Just before Samir jumps in, real quick check. That we have a tradition of having people say hi when they join the call for the first time. And it's not just, it's whether you've joined this call for the first time, because there's different people that go to different calls. And so, Suryadipta Sakar.
Yeah, hello.
Hello.
Hello. Yeah, my name is Suryadipta. I just joined, I guess, yesterday. And so I'm pretty new here. And I just right away wanted to get started with learning. So I was suggested, I have a few friends here who said that I could come join the meeting and learn that.
They didn't lead you wrong. They didn't do you
Yeah.
good. This is what a great call for you to be on. I mean, yeah, and you're welcome to come to any of the calls as well. So
Thank you.
yeah, nice. Good to have you. Anybody else that hasn't gotten a chance to say hi on this call that would like to?
So, hi everyone. I am Devjit Chaudhary. So, this is my first time attending this meeting. I have been in this community for about a week right now, and I am already enjoying the group of people over here. Yeah. Thank you.
Nice. Yeah. Well, hey, so Devjit, if you think about it, like, so last time we spoke, it was, I think, somewhat briefly on, I think, the community call. We talked a little bit about LFX.
Yeah.
And I think, I don't know if I did or not, I might have pointed out some FAQs about how someone might venture into that type of an internship. And I wanted to quickly point out that there were 2 other individuals that were on that same community call talking about the same internship. And guess what? You're the last one standing right now, or you're the one that's showing up. So like,
Yeah. Thanks.
yeah, it's good. It's good. All right, fair enough. Without further ado, well, I guess with further ado, there's an announcement. So Pranav had been working toward, and sort of the community collectively toward, this JWT manipulator 9000. It's just been merged into the Wasm filters repo. And so Samir, as you go to use that, you'll let us know if there are bugs. So
I have
perhaps
already used them. So in fact, yeah,
nice.
so
And with success?
yes.
Nice, good. Nice, okay. So right now, there doesn't need to be a 9001 version of the filter. Okay, good.
Yeah,
So
and
Samir,
I also told my new requirement to him already.
oh yeah, hey, do we have that in an open issue? For
Could you tag me? I have completely forgotten. I've been so busy lately. I'm I'm just swimming in requests. So please do.
Yeah, I'll create that. I didn't create it yet.
all right, well, Samir, over to you.
Oh, great. So I'll just try to present. So yeah, so and this slide is already in our community drive, so anybody can follow along and can reuse. Okay, so this is about the WebAssembly from the lens of service meshes. So ideally, I'll be talking through how exactly WebAssembly works specifically for the service meshes. And this is a very fundamental introduction that is gonna help people to understand why we have started up this meeting in layer 5. Okay, so feel free to edit or add in more info as you go, or as you understand, as you learn more. So yeah, before this, let me tell you, I'll just take some reference which Lee has already presented. So our IT infrastructure has been drastically changed by last few years. So wherein we have moved from monolithic to microservices, and in the deployment strategies, we have moved from VM to container, and then container orchestration with Kubernetes, and then finally service mesh is the one. So what exactly service meshes are doing right now? It is enabling the service first solutions, which is only for the microservice based architecture, where it fits more accurately. But yes, so you can use service mesh anywhere, uh, wherever you want to connect between the services, or you can kind of a decoupling services from one another, and still you want to have reliable connection between them. And few of the architecture wherein you need secure connectivity, and maybe L3, L4, or L7, L5 mm, sort of connections and all. And that is where when we talk about service meshes, most of the service meshes leverage the functionality of one or the other proxy, which enables them to effectively work in a microservice environment. So when you talk about WebAssembly, this is again a very buzzword right now, which is very portable bytecode format, which is kind of a very native to your I would say lower level language or your machine code, and it is very much effective and very fast because it is very near to your machine or machine understanding. So that is where you can say it is near native speed. So why we are using this WebAssembly? To achieve high speed, because nowadays everybody wants their application to be much more faster. And it is as a language which adds into HTML, CSS, and JavaScript. but it is not kind of replacement for them. All those things go hand by hand. So which, like, you can see WebAssembly provides a better performance for all the scripts which has been uh, like mastering in the web delivery networks, or you can say in the uh, client side. Okay, so actually this has been tested in many more browsers which have come recommendation from the W3C, which is ideally the originator of WebAssembly, and it was on 2019. Okay, as I told, this was first innovated to deliver or you can say the for used in client side, but again now it is everywhere, so you can use it in the server side as well as in the client side. So just I was fascinated how it was got birth, so that is why you can see. So this is the birth of WebAssembly, and it was announced on 2015. So if anybody is interested where it was first used, so this is the place. So if you can see this particular game, you can imagine how fast it is, and you don't feel any lag. You cannot feel like you are playing in a browser. So that is where has been ideally tested, and it has got a tremendous kind of popularity after that. And then after, in March 2017, the minimum viable product was declared to be used by other people. And in 2017, of course, it got Safari uh, release wherein it supports Safari. And 2018 again, the group published the public working drafts for the core specification, JavaScript interfaces, and the web API. So this is how WebAssembly got introduced and got birth. And now why we are using, as I have already told, it is usable. It requires a high level code and very simple. It runs like a Docker. So some people say if this WebAssembly has been it, if it could have been originated much before Docker, they couldn't have gone for Docker to run their application. So this is that important for the current modern applications. And again, as it told, it is language agnostics. That means you can write in any language, and you can just make your there are tools wherein you can convert your language to the WebAssembly binaries. So it doesn't really understand any language. That is why it is not dependent upon any language. So as far as the statistics goes, it supports more than 30 different languages. And again, it is a very low level or low level language, WebAssembly. So it is very quick to execute and resembles a native experience. So performance is very good, in fact. So platform agnostic again. So this WebAssembly, though it was first originated or was originated to use in a client side, but now it can be used anywhere. So you can use it in iOS, Linux, Mac, and Windows anywhere, and in your server too. So that is why we are using WebAssembly here. So this is a generic definition, or you can say generic use case for WebAssembly, but let's just go into why we are using it in service mesh. So as of now, if you have followed this slide, so you might have understood what is the extent of performance, or you can see how easy it to integrate with any other languages. So that is where every service message I told uses the proxies, and these proxies are mostly written in either C or Rust, any of those. And it is very easy for this proxy to adopt this particular WASM library. In fact, it is for every language, it is very easy to adopt this kind of WASM libraries. And as proxies plays a very important role in the service meshes. It is also a add-on on the proxies, wherein you can make your service mesh or your microservices more effective or more deliverable to any of the workloads. Okay, so what exactly this Envoy provides for a service mesh? It provides the traffic management, filtering of HTTP requests, policy enforcement, and many more. So these are the filters, or you can say the management traffic, all the enforcement, wherein if you want to bring in your own logic, you can do it with the WASM library, or which is provided natively by this particular, in this case, Envoy. It is natively provided by Envoy with some SDKs, and you can write your own language or according to your business need. So for an example, as I was needing some of the manipulation in the JWT token, which I get from one of the service mesh and pass it over to another one, and that is where we have used the JWT manipulator some binary to do that. So as the service mesh provide a lot of things, so do your do the work how you want. That is where this WASM comes into picture. So in most of the scenario or cases, you can see the proxy WASM, because this is the name used in the service mesh context, because service mesh uses it on the proxies, which is maybe Envoy or maybe any other. So as those are used in the proxy, so those are called as proxy WASMs. Okay, so that is how the WASM has evolved. So this is now in evolving state in service meshes. So if you go to ISTO, it is still on a alpha release state. So which is, you can contribute to, you can learn from them. And solo.io is the most active participator providing this particular proxy WASM support to ISTO. Okay, so how exactly WASM provide the extensibility to Envoy? So a generic application binary interface is there. So wherein it is very easy for you to write something in your own language, convert it to binaries, which can be kind of a .wasm file, and you can again enforce them to any of the services or any of the proxies. So when I talk about the proxy, it is mostly the Envoy proxy, which is used by most of the service meshes as a proxy VM, or you can say the proxy sidecar. So whenever a request comes to any of this sidecar, this particular filter chain, which you have written in a WASM format, will be executed. And then as you have written all of your logic, you will get a fine-grained request, so which is more secure. And again, as I told, you can write it in over 30 languages, and it has an abstraction to allow for the WASM runtime to be used, and it takes very less memory. So which is very good advantages, because it doesn't provide any overhead to your microservices in any manner. So it is very native to the Envoy, because there are the application binary interface has been developed. Okay, so where exactly the proxy WASM fits in the Envoy or any of the service meshes? So if you can see the proxy WASM here, so which is this is a ISTO service mesh, wherein you can see the various proxy component which is being there as a sidecar. So this WASM is added as a kind of plugin. You can think of a plugin. So it is kind of a plugin. So whatever the request comes into Envoy proxy, this WASM filter, whatever you write, that will be manipulating the original logic of the Envoy proxy. So according to this particular explanation which I gave, that is elaborated here. Let's say this is a listener wherein your request come in. Then this is a regular Envoy command, or you can say the regular Envoy filter, which is marked in yellow. And whenever you give a WASM binary to it, it will override those things So for this particular scenario, we have the HTTP connection manager wherein we are pushing the WebAssembly. Okay, so when you put the WebAssembly, then the request will follow from here, then go here. Then whenever it fetches, finds a WebAssembly module, then it follow the route along. So it goes here and here and here. And finally, we have the Envoy router. From there, it will go back to the endpoint of this manager. And from there, it will go to the service. So this is what happens inside an Envoy proxy when a request comes from here. So starting from the listener to the request comes out of the Envoy and enters into the service. And there are few fun facts, like it's just a, if you know about Envoy, this is also very much known. So you can do only the patch operation because there is already some logic written. Now you want to override that, which is a patch operation. And that is why, so how do you ideally build your proxy WASM for the Envoy? There is a CLI tool, which is, you cannot use it for your production workload, of course, but you can play around. There is a WASMing, which is from the solo, and you can just go ahead and download the CLI, and there is a very much
Yeah. So Samir, what about what Meshery does?
yes, so that is why I'm coming down. So wherein you can play around here, but if you want to write of your own, then we also have something here. Okay, so this is ideally in our layer 5.io, where is our all the WASM filter has been listed. So what you can ideally do is you can go here, go to the src folder, wherein you can find a lib.rs. Okay, so in this lib.rs, whatever you see, it is ideally a Rust code, and it get when it is get built, it produce a library of the binary, which is a .wasm. And this wasm you can one second. Okay, so this wasm again can configure with your service mesh. So how to do it? You can run it as a kind of, one second. Okay, so once you write it, then you compile it, then you get a wasm binary, then you have to inject it to your proxy. So how to do it? You can do it via the manifest files, which is again part of this. If you can go to wasm filter, you can see the manifests here. This looks something like this. Either you can do it in a Docker, or I'm not finding where exactly the, yeah, sorry. Okay, let me get it from here.
I guess the manifests and that level of detail, they can slowly just absorb. So, okay.
Yeah, so
Now,
that's all.
yeah.
Yeah, so that is what I wanted to just give. So this is how it happens. So there are few important info. So if you want to get started with Rust, then it is here, which is a like SDK from Proxy Wasm, and you can write in. And there are list of envoy filter, STO. So where exactly you can do the manipulation. So these are the filters here. So you can see that is where we can do the manipulations. Yeah, so that's all. Yeah, so thank you. Over to you.
Can I ask a question? So,
Yes.
so the question is, so you showed about a compiler, right? I think it's a compiler from Solo.io. So similarly, there's one from Meshery as well, or
No, we are
No.
using Cargo. As maybe Pranav can provide more info on that.
No, so the WASME, it's not quite a compiler as such. So what it does is it's, I guess, a CLI tool that calls upon other compilers. So you have, okay, taking Rust, for example, if you create, what do you say, a WASM filter in Rust, you would have various packages like WASMPack, WASMOpt, and so on, which actually build your WASM binary from the Rust code, just like compiling a C++ project. Similar to that, it will compile your Rust code to the WASM binary. Now, WASM binary, as Samir mentioned, is quite close to machine language, but not quite. So there is still a bit of interpretation to be done. It can be compared to Java bytecode, and that WASME CLI tool, it merely calls the respective what do you say, tool chain to compile it, and on top of that, it provides you interfaces to I guess, upload it to your own registry and all. Now, where Meshery comes in is that regardless of your sort of deployment, and so it wants, okay, so what we are doing here is we're creating a sort of interface where you can take those binaries that you create. So this can be either manually compiling it in whatever language you want, or through the WASME tool, or whatever poison of your choice. And you could upload it, and you could then apply it to any aspect of it. So I'll be demoing Image Hub very quickly, so you guys can see live how the filter actually works. So I guess I'll explain that as we go ahead. So if anyone has any other questions, no, if anyone, like, if there are no other questions, I should continue, but please do go ahead in case you do. Okay, no one? Going once, twice, and okay, I'm going to take over now. So, okay, hi guys, I'm Pranav, and I'll be presenting the, okay, if this allows me to share my screen. Okay, yes, it does. So I'll be presenting the Image Hub application, which has been there even before I joined Meshery. So this is a dinosaur, but it's a very good dinosaur. So just a brief recap of what's going on behind the scenes. Essentially, you will have a certain service mesh. Over here, this image depicts the console architecture, and you will have a service mesh running here. This is the control plane, I guess. And some of these service meshes use something called Envoy proxies. Now, these are traditionally used because without these proxy sidecars, normally your traffic would have to go through quote unquote centralized a registry in order to talk to another pod. So you have pod A or foo over here, and you have pod bar over here. Without these proxy sidecars, you would have to be routed through a central thing up here somewhere. It's not depicted in the diagram, but with the proxy sidecars, your pods can directly talk to each other. Another side effect of that, or sort of A planned effect is that, all the traffic going in and out of the containers would be passing through your sidecar. Now, every pod spawned has one sidecar, and all the traffic to and fro will go through these sidecars. What that allows you to do is it allows you to have these WASM filters, which I'll be getting to in a short bit. And these filters will basically receive whatever traffic in or out according to what you've configured them. And that code that you've typed up, each packet or each request it receives, your code will be run over it, and you can do a lot of crazy stuff with that then. So in our example, Image Hub, one misconception is Image Hub is a hosting sort of project, or like, it's where all these WASM images are hosted. That is not quite true. Image Hub, as you can see in the description, is just a sample application to demonstrate the capabilities of WASM filters. So in our case, Image Hub, it samples something like Docker Hub. So over here, I've logged in here. I'm going to keep, grabbing your attention and getting you to look at this request response site tab over here. But basically, through the Meshery management UI, currently I'm running these processes locally. So this is my Meshery server. This is my Meshery adapter, and there are a few custom changes. There are, it's still a work in progress, and it was broken, until 10 minutes into the meeting. So yay for it working currently. If anything goes wrong, don't blame me. Okay, where's Chrome? Yeah. So getting back to Chrome, I basically used Meshery to deploy Istio. So I just clicked on Istio, and you have this managed service mesh lifecycle. So I deployed Istio here, and for the sample application, which is Image Hub, I click over here, and I have deployed Image Hub. Now, traditionally, in such an application, you would have a sign up and login. So let me just sign up with test. Okay, I've already created an account, so I'm just going to skip it. So it's going to be test and test. And yeah, successfully logged in. So this is supposed to mimic, how you have various images on Docker Hub, and you can hit download to download those Docker images. Similar to that, we have another app trying to mimic that. But when you hit download, you only get this pop-up saying image pull request in progress. Now, the people who have deployed this app, they don't want to give unlimited downloads for each user. So right now, when I hit sign up, I can select the plan. Yes, it's flawed that it doesn't ask for your credit card, but I don't think that's that important. So the enterprise allows 1,000 image pulls, quote unquote image pulls. Team allows 100, personal allows 10. And when you go ahead, okay, this should, okay, it says unlimited, but I've limited it to 1,000. So this gives you all the information you want. And you can upgrade the plans, but this is not something we have to concern ourselves with. Going to the hub, ideally, you should be able to click this download button. Since I have signed up with the enterprise account, I should be able to click this 1,000. If I had done personal, I should be able to do it 10 times. And then a warning pop-up would come in. Now, all of what I've told you, traditionally, if I ask you to create this application, you would hard code the logic of, okay, fine, I'm going to, what do you say, I'm going to have my user make a request. He's going to send me some authorization token. So this authorization token is actually a JWT, and this contains your username along with the plan that you have. So now what your application might do traditionally is it'll look at the username. It'll say, okay, fine. In the database, okay, yeah, here's the username. Let's say Pranav is the username. So, okay, I found Pranav. How many times has he pulled? Okay, he's pulled 9 times, 10 times. So I'm going to block him the next time. So that kind of logic you would be coding into your application traditionally. Now, the magic of WASM filters is, what if I told you you do not need to include that code in your application at all, and you could let a WASM filter instead dictate that logic. So you have your rate limit filter, and you have this is the Rust code for it. And over here, after running the compiled the WASM tool chain, build tool chain, you get this binary over here. And this binary, using certain scripts, you then hopefully we do like soon enough we make it easier for you to apply it. But currently we have to use YAML files and apply them manually. So once you do apply them, I'm going to show how Meshery can automate it in its current state. So I have, what do you say, give me a second. Yeah, I have my filter ready to go. I just, okay, I have to set the namespace. I apologize. So I set the namespace, I deploy, and voila, we got our, filter up and running. A tiny thing that I need to do right now is, just give me a second. CTL get pods. So let me do a watch just to, yeah. So you can see now new pods have spawned, and this pod will make sure that whatever traffic comes in, it will take a look at the jot filter, at the jot that the user would send, and it will then help you keep track of the traffic and the user and the number of pulls the user has made. So why don't we try that out? So if you can see, currently the request looks pretty normal. The response also looks pretty normal, and you can see it's on Envoy whatever. And now let's hit the sign up again. Let me just hit reload. Okay, I'm going to create new user, and I'm going to keep personal for the sake of the demo, and I'm going to sign up, and of course it fails. Yeah, so remember how I told if things break, don't blame me. It's broken. Rudraksh, do you have a backup?
So what's happening exactly with yours?
503. It's hitting some error. Give me a second. Let me just find
So-
out if this is fixable or not.
This is exactly why I asked. Mine is facing some troubles with RBAC, so I'm not sure. I'm still trying to troubleshoot.
I don't know why it always happens at the worst possible time. So just give me a second. No, this is fine. Container,
You'll have to specify a container as well.
Okay, fine. Just give me a second.
No, I mean kubectl logs and name of the pod.
So this is the name of the pod, and
-c.
oh, okay, that way.
-proxy.
Proxy, huh? Okay, of course not.
Okay, so did you apply the operation? Or
Yes,
did you?
yes, I applied. Okay, fine. So technical difficulties. Basically, it was working right before I switched on screen share, and what should happen is that logic should be ideally executed on the WASM filter itself, and I'll just show the okay, no, showing the code, it might take a long time, so I guess for the next meeting I'll save this and I'll get it working. Okay, this is not at all embarrassing.
Oh, I mean, one, you weren't intending to give the demo, so having to scramble just before is totally reasonable. And then two, actually the main point of, I mean, Pranav hit on all the main points of what of the purpose of the demo, which is, I mean, like had he finished it off, you would have just seen either something being rate limited or not rate limited. Like you'd have just seen it happening in action, which would have just been the ability to refresh the screen or not, like click the button or not. But the rest of what he had said was really the important bits of helping people grasp the concept that to Joshua's recent question. So Joshua had two great questions, and these are the wrong. And one of them was, hey, like, neat, cool. Joshua, I'm going to put some words in your mouth and say, hey, this WebAssembly stuff is intriguing. Interesting. Okay, fine. Why should I spend time coming to understand how this type of thing works and what's all possible? And like, what's really compelling about this? And some of it goes back to what Samir was saying about the characteristics of WebAssembly. Super small, quite secure, portable, except like a lot of the same characteristics that you would like refer to Docker as helping promote, and part of the reason that it came to popularity is for some of the same ways that you would characterize WebAssembly. So pretty interesting, like it becomes compelling that you could, the example that he gave was like running that Unity game in your browser. Like that's kind of ridiculous. And so, okay, fine. Taking that compute power and those same characteristics over to build in network intelligence in the network. Like, okay, interesting. So to your question, like, okay, what can be done with it? And it's like, well, this sample application that Pranav is showing is he's saying, well, hey, look, like, imagine you're the product owner for, by the way, I should put up I was just writing part of a chapter that's going into the service mesh patterns book. And it kind of says something like, well, say something like this, like there's I don't think it'll coin a term, but it talks about serverless pricing. Serverless pricing. What the hell is that? Well, it's actually kind of what what Pranav is showing, which is, or it's a follow-on to that, which is to say, today, if you're using as an example of a capability you might get out of WebAssembly, is basically implementing business level logic. So in this demo app, it's showing that anyone who can click a mouse, like, and I don't mean this in a derogatory way in any sense, but like if a product owner, product manager wanted to change the pricing model for, or the rate, like switch around for given subscription tiers, how much activity a given account can have based on that tier, they can go over and mouse click their way to changing that. And in moments, have that whole model affected, as opposed to in months and months and months of development, development team sprints to go change that logic, work with the operations team to go implement that, maybe that logic in somewhere else. That's quite powerful and get exposed to them right away. It's pretty interesting. If they want to look at, well, is that the right decision? What telemetry, what information metrics do they have to understand like where that inflection point is between, like if someone's really going to buy the next higher level of their subscription, of their pricing model, they'd have all the telemetry right there to say, well, yeah, like it looks like it would, because there's any number of these people, and we can tell who those people are because we can see their jot, or we can see their session, and like they're doing these behaviors. And so, okay, like this becomes a product in this sense, like in this example, this becomes, well, a development team's tool, a service delivery team's tool, a product manager's tool to be able to do that in the network with the existing infrastructure through configuration. They're just configuring the way that their product is being sold. Whoa, that's pretty cool. And the developers go, thank God, praise God, because I didn't want to work in that boring crap of refactoring the subscription model based on a whim, based on you thinking it was going to work better. And you coming back 2 months later to tell me you want to change the model again. It's like, you know, so it's a win for everyone. I think to round off the answer to your question, which was a little more generic, and it was like, hey, what else is the value? So that's interesting. Great. You can implement some business logic. Okay, well, what else is there valuable about WebAssembly and the way that this works inside of Envoy-based data planes at the moment? Not that other proxies don't have plugin models. They do. If you take a look at, there's a model within Ambassador for plugins that are written in Golang. There's a model in Nginx for plugins that are written in C or Lisp or something else. There's a model in Traffic that for plugins that are written in Golang. So this notion that you can extend the network and its intelligence in these proxies to something more custom is pretty interesting. And then there's another component of that is that, well, okay, yeah, but you can write that in a native filter. So like to Joshua's question, like what's better about WebAssembly than just a native filter? I can go write the custom native filter to do that thing natively to Envoy. It's like, yeah, and that can be the right answer. That could be the answer. The reasons that someone might use WebAssembly filter instead of a native one, they might not, is actually in part the study of our folk. It's like, it's not based on dynamicism. It's like, hey, if you have a running Envoy and great, it's deployed, it's running, and you're like, yeah, we need to add this filter. We need to have a filter that we've written to do this. Okay, we can build it natively, rebuild the Envoy image, etc. Roll out that to our infrastructure, and great. Like we'll bump, you know, we'll rev the infra. Like we'll roll out a new version because you got to get a new proxy in there that has that filter. It's like, well, okay, but wouldn't it be nice if we could just dynamically leave the same proxy in place, but just unload this sucker? And then like also dynamically load in, well, let's load up 3. And maybe based on something that's happening real time, like, oh shit, this thing's happening real time. Okay, we need another one inserted in a chain behind the first one. It's like, oh, damn, all right, that level of dynamicism, the ability to unload and load, either based on signals or some human, like, oh, that's pretty, okay, that's intriguing. Like, yeah, there's a little bit of virtualization tax that's gonna go on between something that's native versus something that's running in this virtual stack machine running inside of a WebAssembly. It's like, well, what is that overhead? Well, I don't know, go watch the presentations that were given over here. And we need to fix this domain because it's currently down, but there's slides that talk about literally exactly comparing what's the difference between this discretely studying the effects of individual traffic control functions. So what is the overhead of native versus WASM? Well, good God, that's a complicated question to answer, actually. That's why you need some tooling like Meshry to say, I don't know, what's your custom filter? I don't know, you test it. Okay, here's Meshry you can use to sit there and test and run those tests to see what the difference is. Great. And then what if I want to, like, okay, great, I understand the difference now between what that overhead is, but is that normal? Like, am I doing it really well? Or am I doing it kind of piss poorly? Like, I don't know, hey, Samir, how's yours running? Well, like, wouldn't it be nice if we had a common framework to exchange and talk about that? So that's what this is about, is a common framework for characterizing the performance and understanding that and exchanging it, which is part of the need in this ecosystem. Another need is in part what Joshua was asking now, which is, you know, is there a standard across various proxies for writing these extensions and filters? In other words, are the filters portable across different proxies in the mesh? It's like, well, that's an awesome question. There's a couple of ways to arrive at that. The answer right now for our industry is no. That doesn't mean that they're like, hey, this community in specific and these, like, that's something very much desired for our part, because hopefully, just like WebAssembly, the contributors here are able to write once and run many or run anywhere. So it is so there isn't a standard. The Image Hub example that was originally presented at DockerCon 2020, a year ago, that was running on a console service mesh, not Istio. Console is Envoy based in its proxy.
Lee, sorry to interrupt, but I got it working now.
Nice. Okay. Yeah. Feel free to grab the ball if you would.
Sure. So, yeah. Okay, cool. So I managed to create that personal account that I was talking about. So let's go ahead and log in. And yep. So if I click this now, you'll see image pull request in progress. And perfect. So you can see over here, the rate limit. Actually, this is supposed to represent the number of times you've pulled. And what's happening right now is that if you can look at this diagram, okay, no. I apologize if my laptop's lagging. It's running everything at once. So, okay, so over here, this basically uses a WASM VM, which you can think of like a JVM. And it's storing the variables like, okay, I see this user and it's keeping track of all of that in memory. And so when it sees a jot coming in from the user test, and it'll just increment the count, and it'll check the plan type as well. And because it knows what sort of plans are there, you pass it through a configuration. It also knows the limit for that particular plan. So it looks at the plan type and looks at the number of requests the dude has made. If he's made too many, it prevents this traffic from being forwarded, and it just blocks then and there, and you get a message saying, hey, this is you've gone over your limit. And if it isn't, it forwards it, and the container then processes it further. And a benefit of this is that your containers don't waste time looking at something that they don't need to handle. So all of it is being done magically within this filter. So I'll just show you the incrementing part as well. So I'm going to pull a couple of more times. Oh god, it's lagging. Yeah. So you can see the thing has gone up. I'm just gonna click this a couple of times. Okay, Lee, just anything you would like to say while I click this 10 times? No? Okay, cool.
Just that portability, there isn't a standard with respect to portability. But in practice, the image hub as an example and its filter, you can see them deployed across two different meshes. And so, so the answer I was giving earlier about no is like no with respect to a standard. So, but in practice, like given the commonality of an Envoy-based data plane and its application binary interface, it may we're banking on part of that being true, that you'll be able to use these across Envoy-based data planes.
All right. Yeah. Thanks.
Okay, so
I showed my demo.
So one thing that we didn't, so I got to yapping. It took a little bit of time, but we also had two presentations, which was fantastic. One thing we didn't get to, so Anirban, are you on the call? I know.
Yes, Lee. Yes, Lee. I'm there. Yeah.
How do we not do the disservice of trying to cram, 10, 15 minutes into 2 minutes?
Okay. Sure. I can do that. So I will just shorten it so let me just present my screen.
So by the way, for everyone on the call, just like it's inevitable that Anirban's going to present something pretty interesting and juicy. And we're going to ask questions, and about 20 minutes is going to fly, 15 minutes is going to fly by or something. And so I just wanted to say, if you've got another call and you need to drop, very nice to see everybody today. Hang out if you can. Anirban, maybe we should just, since I said that, and since it's like 1 minute left, like we should just say, hey, if you want to stay around, please do. I know I've got questions and things to learn. So, if you need to go, we see you all next week at the same time. So.
So, okay, guys, I'll just shorten it. I'll not take much of your time. So, basically, you asked me to prepare a demo on Envoy traffic mirroring, but the actual demo, I'm facing some issues with Docker and all those stuff, so I could not complete it. So, probably, definitely next week, I will complete it. So, I've just the presentation part I'm showing today. So, today I'm talking about the Envoy traffic mirroring, and uh, first of all, we talk about what is Envoy. So Envoy is a high performance proxy. So it can be applied at different layers and mechanisms are there. And it is it is nothing but a service mesh implementation. And Istio is one of them. And so definitely we use Istio very much for the service mesh implementation. And uh, basically what we do is the traffic handling part we actually can be done using some sort of filters, and that filters or a chain of filters, and this allows a couple of things. One is access control and one is like the rate limiter, and also it can help you to have some billing based on the who is authorized to do what, like based on what subscription he has taken. So all those things can be taken care. And then I talk about what is traffic mirroring. So traffic mirroring or shadowing is a concept by which we mirror the copy of the live traffic to the from a local code base to the some remote code base. So the mirroring, the basic example of a mirroring service is mail archival service. So basically you people like or providers like Barracuda or even Microsoft, what they do is whenever you have that email archival service, there is that option to mirror your archived mail for an user to a remote data center. So that data center is generally on the cloud, and you can mirror either the whole of the mails for the user, or you can just mirror a part of it. So that is what we do as part of the Envoy traffic mirroring. And so as I said, that it can happen for the entire traffic or a selected portion of the traffic. So this is how we can limit the rate of the traffic. Okay, and we can do multiple things with the traffic using this concept. And so what we will do is we'll basically apply a rule to a portion of traffic to either the mirror entire thing or to mirror only part of the traffic. And basically what we do is we create two instances of the HTTP bin service on the remote server, and that's how we use Kubernetes to deploy have this service running parallelly. And then we whatever WASM filter we create, so we use Istio to deploy, and then it can help us to achieve our goals. So, and again the new filters can extend the current features of the Envoy. So that is a good concept. And there are two ways to actually go about it. So first is like integrate the additional filters into Envoy source code and compile a new Envoy version. So basically what it does is we always need to keep updating us, and the drawback as is clear is like we always have to maintain our version of the Envoy and continuously be in sync with the official distribution. And so this is the problem. So what the best solution is to dynamically load new filters into the Envoy proxy at runtime. So this will be adding new features, new capabilities, and we can write our user-defined filters to achieve this kind of traffic. I can say traffic monitoring or rate limitation. A lot of things can be done. Okay, and so anyway, I think everyone has covered this. So my small thing would be basically the filters, whatever we are creating the WASM filter, this acts as a proxy. And whenever normally the communication happens between this entity and this entity through the Kubernetes, but when there is a networking issue, then our entire system can go for a toss. So that is where the proxy helps into helps communication between this entity and this entity directly, not via this normal flow. What happens in Kubernetes? That is the place where we are going to work for the WASM filters. And I think people have taken care of this, so I just put this, so I don't want to go detail into this. And I think this is also explained. So what is the incoming request and what exactly we do. So we basically once we apply the filters, we route the traffic to the service. So basically, what has happened? It's a filtered traffic, you can say. It is not the exact traffic it wants. It's originally coming. So based on our requirements, we can apply filters and then route it. So that's the main thing. And okay, so I think this is also covered. So I think, and okay, basic strategy. So I was just going through some code base. So I have not been able to do much on the code right now. But I just saw some code base where they have written a filter, WASM filter using C++, and they were talking about what exactly we need is like two classes. One is a root class and one is a context class. So the root context is based on the the root, it is like the main user or the admin user, and the lifetime is throughout the VM. And the filter can be used for all those interactions between the initial setup and again the interactions between the proxy and the different entities. And on configure can be invoked by the root context to basically based on the configurations what is done. And then and it again, if the plugin contains one or more WASM filters, is expecting a configuration to be passed in Envoy Proxy. Again, we can override this functionality using some override functions. And so I have not done much. So I was just going through the code, and probably in the next session, probably I will just give a brief of what exactly I'm trying to do, and I probably will give more context on that. So I have put some code base, but probably I'm not fully prepared. I've just prepared a part of it. So let me just present this next time. Okay, and I think these all things are already covered. So I have already taken this VASME, and I have installed it, and I have actually created a small filter, and then I was trying to push it, but I was getting some issue with the Docker, and that is where I am stuck. So probably I have to sync up with Pranav and see how to deploy that stuff. So once my entire setup is up, I think I would be more comfortable to do much more things. So that's it from me, Lee. I think I have not taken much of your time. Thank you.
Nice. That's great. That's definitely progress. There's another component to this is digesting Envoy's capabilities itself, like its existing capabilities to perform traffic mirroring, and then reflecting on, I think, like having understood that, one of the questions that we will no doubt ask ourselves is, what's it missing? Or like, where doesn't this work? Or do people need more controls over this? Like part of what you were saying early on in the presentation is Envoy can mirror the entire thing or a subset of that traffic. It's like, well, how granular can that be? Can it be just a nearbounds traffic? Because that could be a very common use case. Is like, hey, we want to do a canary as an example, but only for a nearbounds traffic because it's okay to mess his up because he's testing and developing anyway. And so, or so digesting what Envoy is capable of already leads us to, hey, what should if you do like. Yeah, boy, I'm trying to be concise and having a hard time. I'll say that one of our use case, like a great use case here, and this has to deal, like, it's not whether it's traffic mirroring or just traffic capturing, kind of one and the same in this case, like to the extent that we can capture some packets, and whether or not they're actively played, replicated and sent somewhere else actively, or if they're just persisted to a data store, to a PCAP file or whatever. I'll make a quick analogy to the thing I think would be really helpful to a lot of people running operating services on a mesh. And it would be one of those compelling things where people say, oh yeah, well, if you just had a mesh deployed, you could have troubleshot your issue because of this capability. And the capability is something like this. If you make an analogy to distributed tracing, where there's a lot of troubleshooting and a lot of helpful information that comes from traces. You look at each of those spans, you're like, oh, that's a massive span. That's such a slow service. We should figure out that SQL query that's taking 19 years to come back. So distributed traces are really helpful for like white box monitoring or like deep insights. And okay, but there's a cost to tracing those. Like, hey, how often are you going to sample those suckers? Like every single time? Maybe if you're in a regulated industry or something, but it's like, yeah, go ahead and like go purchase, may as well go work on a purchase order now for those hard drives you're going to need to have to, like for the CPUs that you're going to need to have to do. It's like, okay, well, we actually don't, for a lot of people, it's like, no. Like we occasionally want to take a look at those distributed traces, and it's like really important for like the trailing last 3 days. It's pretty important for us to see those, but like beyond that, we could we could aggregate our samples. Like we don't need the high fidelity. We can have lower granularity going back in time. And okay, great. But there are some vendors in the distributed tracing space that handle those types of use cases and make that easier to do. They also have worked on things where, oh no, why don't you just sample, keep those samples only as and when there's an error 500 or some, only as and when the latency gets so bad that like there's something going on, we should start to investigate. Like do it intelligently. Only do it when you detect an anomaly. Maybe the anomaly was 500, maybe it was super slow, whatever. It's like, hey, this is well-trodden or like fairly well-trodden stuff that I'm saying. I'm not saying something that like, and so part of, okay, for that's distributed traces. Can you play back that same thing that caused the trace to be huge, or that is, can you play back the same, like as you go to troubleshoot your trace, it's like, great, we saw that issue happening, but it's not happening now. It's like, well, I can't repro the issue. It's like, oh no, actually, you want to repro, just click the repro button, click the replay button. Like, so.
Great. That's very interesting, but I feel like, yeah, to handle that much data is the main concern. So, yeah.
Totally, and therein lie, yeah, we were just talking with a professor at NYU, Anirudh Srinivas, I think, Anirudh Srinivas, NYU professor. Some of his students have been in the community contributing. They've been working on actually specifically better algorithms for sampling of distributed traces. Great, that's like really close to the answer that we would need to have if we're going to capture all that traffic. Like again, you're talking about like churning some CPU, churning some disk. Like let's do that intelligently. And so the two examples are kind of interrelated. And to your point, yeah, you really, it would be compelling for Meshry and tooling like it would be compelling for people to come and use it if it has that kind of a capability.
So you need to integrate with multiple things. So I think like a big data kind of might be a database or something.
Or if the system gets intelligent enough, then actually it only captures traffic on an anomaly, and it maybe it's like perpetually capturing, but most of it is going to the bit bucket after 5 minutes, up until it sees a 500, and then it's like, oh wait, save the 10 seconds before, 10 seconds after.
Great, sure, great, thank you, thanks, Lee.
Yeah, no, thanks for that. This is great. This is really good.
Yeah, thank you.
I'm pumped to see everybody learning and sharing. So, anybody have anything else before we clock out? Okay.
I not much exactly, just that I looked into the point that is in the meeting notes, the custom styling for Rjsf. So there are a few customizations that we can add to the Rjsf components, like custom fields, custom widgets, and custom templates. So there is a array field that we can use to change the way the form looks, and there is an object field that we can change to decrease the nested cards basically. So if Gaurav is on the call, maybe he can take a look at them, or maybe both of us can take a look at that after this call.
Yeah, we can have a look.
Yeah, that's just the update.
It's really important, actually. Anything else? Sweet. Well, hey, we'll work on the agenda for next week in Slack. Some of us already have homework, so we already know. Cool. All right. Very nice to see all of you. I'll catch you next Monday.
Thanks.
Bye guys.
Bye guys.
Bye, everyone.
Okay.